So students, now let us talk of direction cosines and generalized electric field equation. I will explain. So first let us talk of direction cosines. Direction cosines. In name itself is there. Cosine means cos and they talk of direction. So here in mathematics it is defined like this. If this is a x-axis and this is y-axis and this is z-axis actually. Now here one point is there called P x comma y comma z. Now this is called OP bar. This is called OP bar. So OP bar is equal to, this is origin, that becomes x ax y ay z az, positional vector from origin to point P actually. So this OP bar is also called as R bar vector sometimes. This is origin. Now let us say this OP bar, it is like this, x, y, z, this is OP bar. Now let us say this OP bar makes a degrees angle with x-axis, b degrees angle with y-axis, and c degrees angle with the z-axis. I am showing here. So let us say this is making a degrees angle with the x-axis and b degrees angle with the y-axis and c degrees angle with the z-axis. Now cos of A is defined like this. Cos A degrees is equal to, that means OP bar or otherwise R bar dot AX divided by modulus of OP bar. So here OP bar is this one, that means XAX plus YAY plus ZAZ dot AX cap divided by modulus of OP means x square plus y square plus z square under root. You get x here. So ultimately cos A is equal to x divided by x square plus y square plus z square under root. Okay. Similarly, cos of b degrees is equal to OP bar dot AY cap divided by modulus of OP bar. That directly I am writing y by root of x square plus y square plus z square you get. So cos c degrees is equal to OP bar dot A z cap divided by modulus of OP. So that is equal to z divided by root of z square y square x square y square z square. Actually this OP bar makes A degrees, B degrees, C degrees with XYZ axis respectively. That means these angles give the direction. For example, this OP bar is an x-axis, then A degrees is 0, then B and C degrees are 90 degrees. So these angles, that means if A degrees, that means if for example, if this OP bar on the z-axis is on the z-axis, then C degrees is 0, then A and B degrees they are 90 degrees. That means these angles are deciding the direction of that. So like z direction, then A, B 90 degrees, C 0. These angles decide the directions and cos is there. So direction cosines they are called as. These are definitions in the mathematics. So now students, one more thing, cos square A degrees is plus cos square B degrees plus cos square C degrees. If you take square and add them, you get x square plus y square plus z square divided by x square plus y square plus z square, that is equal to 1 you get. So cos square A degrees plus cos square B degrees plus cos square C degrees is equal to 1. This is one result. Now I am writing here, note, generalized wave equation, or otherwise electric field equation of EM wave for wave traveling in an arbitrary 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 means arbitrary direction, means in any direction. Arbitrary direction means any direction, that may be in x direction, that may be in y direction, xy direction, xyz direction, any direction. Arbitrary direction means, till now we have studied for wave traveling in what do you say, z direction. Now if wave travels in xyz direction like this, xyz, if wave travels in xyz direction like this, then what is the equation? We have to see. Okay, I am drawing the diagram here. So this is a x axis here, this is y axis, this is z axis. Now let us say this is the wave propagation direction, wave is going like this. So EM wave is traveling like this. In the wave propagation direction, phase shift constant is beta. In some books that is called as k. So beta is nothing but k only. Okay, this is a EM wave propagation direction, this one. That is in x comma y comma z direction, but on the board you are seeing like this. So now this EM wave makes 8 degrees. I am using other ink here. This EM wave makes 8 degrees with x axis, b degrees with y axis, and c degrees angle with the z axis. Okay. Now already you know cos a degrees, cos b degrees, cos c degrees, they are called direction cosines of EM wave here. EM wave direction is like this. And in the direction of EM wave, beta is phase shift constant, or otherwise wave number it is called as. Okay. So dear students, if you project this beta onto the y axis, then it becomes a beta cos b degrees, because this is touching this one. That is named as beta y. If you write in terms of k na, that is k cos b degrees, that is called ky. So in some textbooks they use beta symbol, some textbooks they use k symbol, but in examination, if that person give question from the textbook where k symbol is there, you should not confuse. That is why I am using both the symbols. दोनों symbols use कर रहा हूँ. So now similarly, this beta y means phase shift constant in wave propagation direction. Now it is projected onto the y axis. Beta y means phase shift constant in y direction. Similarly, if I project them onto the z axis, then this is beta z. It becomes beta z is equal to beta into cos c degrees. Similarly, if I project here beta x, phase shift constant in x direction is equal to beta into cos a degrees. If I write in terms of k, kx is equal to k into cos c degrees. So this is z axis actually. This is kz is equal to k into cos c degrees. So here I am writing them beta or otherwise k is a phase shift constant or otherwise wave number in the direction of wave propagation, in the direction of wave propagation. Now beta x is nothing but beta cos a degrees, that is nothing but phase shift constant in x direction, phase shift constant in x direction. Beta y is equal to beta into cos b degrees, that is phase shift constant in y direction. Beta z is equal to beta into cos c degrees, that is equal to phase shift constant in z direction. Now beta bar is equal to, that means in wave propagation direction beta bar is a propagation, this one. Actually beta is phase shift constant or otherwise wave number. So beta bar is nothing but wave number vector. In terms of, you can write bx, by, bz. So beta bar vector is equal to bx, sorry, beta, not b. Beta bar is equal to beta x ax plus beta y ay plus beta z az. So similarly, if you, I am writing just parallelly k bar also. So kx ax, ky ay, kz az, just in the brackets I am putting. So here beta bar is phase shift constant vector, or otherwise this is phase shift, beta means phase shift constant, bar means vector, phase shift constant vector, or otherwise wave number vector in wave propagation direction. So of course here now beta bar becomes what? Beta x is beta cos a degrees into ax, and beta y is what? Beta cos b degrees ay. Beta z is what? Beta cos c degrees az. So here if you take modulus of beta, dear students, what you get here? Beta x square, beta y square, beta z square, that is nothing but this square. I will write here beta x square, beta y square, beta z square under root. That is nothing but I am writing in terms of beta x square means this one. So beta square cos square a plus beta y square means this square, beta square cos square b plus beta z square means this square, beta square cos square c under root. That is equal to, you pull out beta square, then it comes outside, then you get beta square, you get beta outside. So cos square a plus cos square b plus cos square c, this value is what, student? I wrote there in that equation, that is beta into 1. So now what is the conclusion actually? Modulus of beta bar is equal to beta, and that is nothing but modulus of k bar is equal to simply k. Okay. Here, after studying this much, already we have seen OP bar, that is also called as R bar, is equal to positional vector xax yay plus zaz. Okay. Here situation is like this, x axis, y axis, z axis, and this was the wave propagation direction, wave direction. Now in this direction beta bar vector is there, beta bar vector. Now if I take one surface which is perpendicular to this one, on the surface point I will draw bigger surface, students. So on the surface there is one point called px comma y comma z, that px y z keep changing on the surface. Now if I write op bar here, once again this makes 8 degrees, same diagram only, but I am talking of surface which is perpendicular to the wave propagation direction. This is b degrees, this is c degrees. So here op bar or otherwise r bar is xax plus yay plus zaz. Now after discussing this much, electric field equation of EM wave traveling in any direction, arbitrary means jaisa marji hai waisa, x direction, y direction, x y z direction, like that. So now electric field equation, wave may travel in x direction, y direction, z direction and function of time. If wave travels in z direction, only z is there. If wave travels in x comma y comma z direction, all components will be there. So E naught, that means that is the initial value, e power real part of e power j omega t minus beta bar dot r bar. That means k bar dot r bar. R bar is also called as OP bar here. This is the way you get equation. So you see, I will link with the equation which already you know after solving this one. So electric field x comma y comma z comma t is equal to, here place may not be sufficient. Okay, I will use the place like this. Okay. Now e bar of x comma y comma z comma t is equal to E naught, then real part of e power j omega t minus beta bar is nothing but beta x ax plus beta y ay plus beta z az dot, that is x ax plus y ay plus z az. Okay. Now ultimately that becomes E naught real part of e power j omega t minus ax dot ax is 1. Beta x is what, dear students? I will write in next step. So beta x into x, of course, minus, I can put here overall this bracket, so some adjustment, this type of bracket na. So no need to write for every time minus minus. So beta x into x plus beta y into ay dot ay is 1 plus beta z into z az dot az is 1. So this is the equation. Now ultimately beta x is beta cos a degrees, right? So that is equal to E naught real part of e power j omega t minus minus of beta x is beta cos a degrees into x plus beta cos b degrees into y, this one, plus Okay, I will write here, students, so that E naught into real part of e power j omega t minus of uh, beta cos a degrees. Already you know these things, beta x you know, na? That is beta cos a plus beta into cos b degrees into y plus beta into cos c degrees into z. So this is the equation. You can remove this one. Okay. So here simply it is beta x into x. That means phase shift constant in x direction multiplied with the x, phase shift constant in y direction multiplied with y, phase shift constant in z direction multiplied with z. So if you write this by removing this exponential, you get E naught into what is real part. Actually, this is j, na? This is j. If you write take real part, you get cos E naught into cos of omega t minus beta cos a degrees minus beta cos b degrees into y minus this is beta. So this is beta cos c degrees into z. After listening this much, what you have to remember is आप लोग क्या याद रखना है इतना सुनने के बाद? Only this equation you have to remember. These two equations. Anyway, this also no need to remember. If you remember this equation, taking real part means cos. So this single equation you have to remember, students. And no need to read anything. Remember the single equation. And once if you remember this one, then you can see here these things also you have to remember. This is a beta vector, and this also you remember. ओके ये भी याद रखना है. और इसके बाद इधर ये जो है मॉडुलस ऑफ बेटा बार गिव्स बेटा, दिस इज वन थिंग, एंड दिस वन यू हैव टू रिमेंबर. ये वाला याद रखना है. सो अभी आपको मैं लिख रहा हूं व्हाट इज द फेज वेलोसिटी इन द वेव प्रोपगेशन डायरेक्शन ओमेगा बाय बेटा. व्हाट इज दैट बेटा? दिस वन. What is the phase velocity in x direction? Omega divided by beta x. Like that I will write there. Some little bit discussion is there. So this is the equation which you have to remember here, friends. In sometimes in the questions, they give this equation. Simply they won't put RE. That is not correct way. But those people are like that only. We can't do anything. So you don't bother about that. So it is in phasor domain. Phasor domain means it should be in e power j terms. Then once if you take real part, you get time domain term like this. Anyway, I want to tell you one special case so that example, student, example. If wave travels in z direction like this, this is y, this is x. If wave travels in z direction, okay, wave direction. If wave travels in z direction, then what happens? Here A becomes 90 degrees. A degrees means angle between x axis and wave propagation direction, that is 90 degrees. And B means angle between y axis and wave propagation direction, that is also 90 degrees. Then C means angle between z axis and wave propagation direction, it is traveling in z direction only, 0. Now if you want wave equation, you substitute in them. So for wave traveling in z direction, you see this equation how it becomes E naught into real part of E naught into real part of e power j omega t minus A becomes 90, so this is not there, and B becomes 90, so this is not there. C becomes 0, cos 0 is 1, you get beta z. We were studying these equations only, and you substitute in this, for example, that is equal to E naught into A 90, this is 0, this is also 0, only this is there, this is 1, so beta z comes. So E naught into cos of omega t minus beta z. This equation, we were studying this equation only for wave traveling in z direction. So in that way, now I linked this equation with the equation which we have studied already. Now I will write one point here. Here, what is the velocity of the wave in wave propagation direction? Answer, phase velocity is equal to omega by beta. So here Vp is equal to omega by beta. Of course, you have seen, student, that is nothing but here omega divided by, anyway I will write that here, omega root mu epsilon. Beta is omega root mu epsilon. So this gives phase velocity in wave propagation direction. Phase velocity in the wave propagation direction. Phase velocity in wave propagation direction. Vpx means phase velocity in x direction. Phase velocity in x direction. Vpx, that means omega by beta x. So here omega divided by beta x is nothing but beta cos a degrees. Now this becomes what? Omega by beta becomes what? Phase velocity in wave propagation direction divided by cos a degrees. Now what is this Vpx actually? Phase velocity in x direction. Now phase velocity in x direction is greater than phase velocity in wave propagation direction because cos a degrees is always generally, if it makes some angle, definitely it is less than 1, dear students. Cos a is always less than 1 if it makes some angle. If it makes 0 angle, that is 1, that is different issue. If it makes 0 angle with any axis, then no need of this discussion. So this discussion is there whenever wave makes some angle with x axis, some angle with y and z axis, then in that case this is less than 1. Okay, if some angle is there, if a bar not equal to 0, if a degree is not equal to 0, then automatically this is less than 1. Okay, that is why in the denominator less than 1 is there, means in the numerator that is greater than 1. Okay, actually this can be given in one statement form also. Phase velocity in any direction is always greater than phase velocity in wave propagation direction. So if it becomes 0, 0 angle, then it is 1, then it becomes equal. But we are assuming that definitely it makes some angle. So in that case, this is the situation. Okay. So ultimately, student, for other cases also, Vpy is equal to omega by beta y. So that is omega by beta y is beta cos b degrees. So omega by beta here, na, that is phase velocity in wave propagation direction, cos b degrees, that is phase velocity in y direction. In this way, phase velocity in y direction is also greater than phase velocity in the wave propagation direction. Similarly, Vp z is equal to omega by beta z, omega by beta cos c degrees, that is phase velocity divided by cos c degrees. So this is this one, and phase velocity in z direction is greater than phase velocity in the wave propagation direction. In this way, you can see that lambda is equal to 2 pi by beta. Okay, students. Now, what is this lambda? Wave length in wave propagation direction, where beta is equal to omega root mu epsilon. That is general formula, omega root mu epsilon. Now, lambda x is nothing but 2 pi by beta x, that is nothing but 2 pi by beta x is beta cos a degrees. 2 pi by beta is lambda actually, so lambda by cos a degrees. That gives lambda x means wave length in x direction, and once again here lambda x is greater than lambda. Okay, because a degrees, if a is some value, then cos a is always less than 1. Similarly, lambda y 2 pi by beta y. So 2 pi by beta y is beta cos b degrees, that is lambda divided by cos b degrees. So this is the wavelength in y direction, and lambda z is equal to 2 pi divided by beta z, that is nothing but 2 pi divided by beta into cos c degrees, that is lambda divided by cos c degrees, that is equal to that is actually wave length in z direction. Okay, these are general discussion, and what is important is that wave equation is important. You students should understand. I am telling you, remember this one. This wave equation is important. In the examination, the question may come in exponential form or otherwise cos form. Beside x, whatever is there, that is beta cos a. Beside y, whatever is there, that is beta cos b degrees. Beside z, whatever is there, that is beta cos c degrees. Then once if you write beta cos a value, beta cos b value, beta cos c value, then their squares give beta square. I am telling this one. Here somewhere it is there. This one. You will take square of this, then that gives beta square. Okay. If you want, I can write that also. So here from this now, students, from this one, I am writing beta square is equal to, here itself now, where is that vector? If I write there, that is more meaningful for you, so that you can understand. Here you see, what is modulus of b? Modulus of b is equal to root of beta x square, beta y square, beta z square. Then take whole square. What is modulus of b? Actually, somewhere I wrote here modulus of b is nothing but beta. So beta is equal to beta x square, beta y square, beta z square under root. Now from this beta square is equal to beta x square, beta y square, beta z square. So students, here also you can see beta x square plus beta y square plus beta z square is equal to, beta square is common, then cos square a plus cos square b plus cos square c is 1. So beta square is equal to beta x square plus beta y square plus beta z square. This you have to remember. Why I came from here to here? I told you beside in examination they give cos term or exponential term. Beside x 5 is there, for example. Beside y 6 value is given. Beside z 7 value is given. Then if they ask you to find beta, then beta x is 6. 6 square plus 7 square plus 5 square plus 6 square plus 7 square. It is 5 is given here. Here 6 is given, here 7 is given value in examination. So 5 square plus 6 square plus 7 square gives beta square. From that you can get beta value. If you substitute that beta value here, then beta x is given. Then from that you can calculate A degrees also. We will solve the question based on these two questions are there. We will solve them, you will understand that. Okay. So students, let us solve this question. So in this question, it is given a plane wave of wavelength lambda is traveling in a direction making an angle of 30 degrees with the positive x-axis. So you take the axis here, this is x-axis, this is y-axis, and this is z-axis. That EM wave is traveling in some arbitrary direction, then that EM wave makes a 30 degrees angle with the x-axis and 90 degrees with the positive y-axis. See, if EM wave make 90 degrees with the positive y-axis means that is on xz plane, because y-axis is 90 degrees to xz plane. That means that EM wave is on the xz plane. It is going like this, and it is given that here don't bother about this angle. I will be writing that. So it makes how much angle with the y-axis here? It makes 90 degrees with the y-axis. So it makes 90 degrees. That is b degrees is equal to 90 degrees is given. That EM wave makes 90 degrees with the positive y-axis means that is on xz plane. 90 degrees with y-axis means that is xz plane. Now it is given 30 degrees with the x-axis. So with x-axis it makes 30 degrees. That is A degrees is equal to 30 is given. Now this EM wave going like this, it is given. It makes 90 degrees with y-axis and 30 degrees with x-axis is given. Then automatically with z-axis it makes 90 minus 30, because angle between x and z is 90. So it should make c degrees is equal to 90 minus 30, that is equal to 60 degrees. Now if you know the angles, then you can write the electric field equation. Lambda is given, so that means he is expecting the answer in terms of lambda. So beta is equal to 2 pi by lambda. So if you write the equation, electric field equation is equal to, in phasor form, E naught. E naught is actually initial value of the electric field. He also has given E naught is constant, that means that is initial value. Real part of e power j omega t minus of beta cos a degrees x, beta cos b degrees into y minus beta cos c degrees into z, dear students. Okay. So now this is the formula. Let us substitute now. E naught re e power j omega t minus a degrees is 30, beta is actually 2 pi by lambda, and cos 30 is root 3 by 2 into x minus, here b is 90 degrees, so 0 you get. Then beta is 2 pi by lambda, so c degrees is 60, so cos 60 is half actually into z. So this is the equation, because he is he has given lambda means if you see options he has written beta in terms of lambda actually. So this is the answer, real part of e power j omega t minus 2 to cancel. So pi root 3 divided by lambda into x, so minus pi by lambda into 2 to cancel z you get. So this is the answer. I told you some people actually they have to give RE. If you remove RE, then a cause is written, cause of. But some people they give questions the way they like. Don't bother about them. So if you see the option that is E naught e power j omega t minus pi root 3 by lambda x minus pi by lambda z. So y cap the direction anyway. Here, how do you know that y cap? If you see carefully, the electric field equation has it is telling wave is traveling in x and z direction. So wave travels in x and z direction. For TEM wave, electric field and magnetic field will have a 90 degrees angle. So it is in y direction. Electric field direction is given y direction. Okay. So option is A actually. Option is A. Now, polarization. Let us discuss the polarization. After discussing the polarization, we will solve some questions, and again we will discuss oblique incidence. Okay. Oblique incidence means what is the transmission coefficient and reflection coefficient if EM wave hits the boundary surface at some angle. Earlier we have studied normal incidence. After this we will study the oblique incidence. Polarization. Actually, polarization term comes in material science also. Their meaning is different. Here in electromagnetic wave, polarization means meaning is different. Don't mix up them. Here I have written polarization of EM wave. That means this polarization term defined for EM wave, the definition is written here. But in material science, that is different meaning. Now, polarization of EM wave is defined as direction of electric field of an electromagnetic wave at particular distance. Actually, students, if EM wave is coming like this, if this is radio and radio has antenna, if incoming EM wave electric field is vertical, then antenna is also vertical, then it is vertical polarization, then this radio antenna receives the signal. If incoming electromagnetic wave, for example, radio mirchi signal is coming that has electric field horizontal, then you have to turn this radio antenna also horizontal, so that it receives horizontal polarized wave. That means the electric field direction has significance with respect to receiving antenna. That we will study in the antennas also. Now, polarization of electromagnetic wave is defined as direction of electric field at particular distance. Electromagnetic wave comes out of the antenna, then it travels. Then near the antenna, it travels zero distance. So that is why for wave traveling in z direction, polarization is observed at z is equal to 0. That means just near the antenna, electric field direction is observed. Then electric field direction is called polarization. Then near the antenna, whatever direction is there for electric field, when it travels, then also same direction will be there. So that is why it is observed at z is equal to 0 distance. So anyway, if electric field has x component, then you say wave is polarized in x direction. If electric field has y component, then you say wave is polarized in y direction. But in examination, they give one statement. What is that you see? Polarization is direction of magnetic field. That is wrong statement. Polarization is defined as direction of electric field only, not for magnetic field direction. You remember that one. Now, here in other way, you have electric field x component, y component like that. Then overall electric field is called resultant electric field. So the resultant electric field direction is called as polarization. So both are same, but here in this way also you can write a polarization of EM wave is the trace of tip of the total electric field. So that is nothing but a trace of tip of the total electric field, means that is the resultant electric field. We will solve the questions, you will understand. With respect to time at a particular distance, both are same. That means here polarization of EM wave is the trace of the tip of the total electric field, means direction of the total electric field only. If you solve question, we will understand. Anyway, I will solve some cases also. Now, till now we have studied wave is traveling in z direction. So let the wave is traveling in wave is traveling in z direction. Then electric field vector, can have electric field x, comma electric field y components. What I am saying is, if wave traveling in z direction, we have proved that electric field z component is 0. Then electric field even can have x component and y component. So I told you, if electric field has x component, then magnetic field will have y component. Then electric field x component and magnetic field y component carry the power in z direction. If electric field has y component, and then it generates magnetic field x component, and electric field y component and magnetic field x component carry the power in z direction. There are two parts. Now coming to this discussion, in some cases electric field can have only x component. In some other cases, electric field will have only y component. In some other cases, electric field will have x and y components. If electric field has only x component, then power is carried by only electric field x component and magnetic field y component. If electric field has a y component, then power is carried by electric field y component and magnetic field x component. So if electric field has both components, x and y, then both components carry little bit power. Then total power is sum of the power carried by electric field x component and electric field y component. So it depends on the person who is sending the electromagnetic wave. So now case 1, if electric field has Ex only, that means x component only, then direction of electric field is x direction. So wave polarization is wave is said to be polarized in x direction. So if electric field has Ex only, then wave, that means EM wave is said to be polarized in x direction only. Then case 2, example electric field is equal to EI0 cos of omega t minus beta z a x cap. Now electric field has only x component, student, like that. So now wave is said to be polarized in x direction. So case 2, if electric field has EY only, then wave is said to be, that means electric field has only y component, na? Then polarization is in y direction only. It is very simple. If EY, if electric field has EY component only, then wave is said to be polarized in y direction. Okay. Here no need to write only. Okay. Polarization is in x direction. Okay. If you write only also no problem. Ex example, E bar of z comma t for wave traveling z direction. So EA0 cos of omega t minus beta z ay cap. That means electric field has y component. So that is why wave is said to be polarized in y direction. Okay. Now case 3. Case 3. Electric field has Ex comma Ey components and both are in phase. Both are in phase means both have same phase. That is the meaning. Both are in phase. Then resultant electric field tip. That means this only. That resultant electric field tip follows linear equation. So wave, that means EM wave. Wave is said to be polarized. Wave is said to be linearly polarized. Wave is said to be linearly polarized. Okay, we will take example and we will solve that one. It is given, student. Example we are solving. It is given. That means the person who is sending electromagnetic wave is sending the power in such a way. Power is carried by electric field X component as well as Y component. Then only we discuss this one. So it is given electric field for wave traveling in z direction is so here Ea into cos omega t minus beta z ax cap, okay, ax cap, okay, plus E b into cos of omega t minus beta z into ay cap. It is given, student. Given electric field is this. Then find polarization. Then find polarization. Okay, that is the question. We will solve that. Then this equation is matching with the statement. You will see. So electric field has Ex. That means beside Ax cap whatever is there, that is called Ex, and beside Ay whatever is there called that is Ey components, and both are in phase. You see the cos term. You see the cos term. Inside cos omega t minus beta z. Inside cos omega t minus beta z. Same phase is there. So you call them as they are in phase. Then electric field tip. That means electric field tip follows linear equation. I will solve this one. You will understand that one. Okay. Now here beside Ax whatever is there, na student, this one, that is called electric field X component. Beside Ay whatever is there, na dear students, that is called electric field Y component. Okay. Now let us write them here. And so you take the equation of electric field X component. Take the equation of electric field Y component. Then I told you polarization is observed at particular distance. In general, we observe at z is equal to 0 distance, I told you. So dear students, electric field X component is given as Ea into cos of omega t minus beta z. And the electric field Y component is given as Eb cos of omega t minus beta z. So these are given. Now, polarization is observed at z is equal to 0 distance. So in this case, Ex becomes Ea into Z0 means cos omega t. Now Ey is equal to Eb into cos omega t. Okay. Now somehow, how you get resultant electric field equation? Resultant electric field equation means electric field has X component and Y component. Somehow use your mathematical skills and get the equation which gives the link between Ex and Ey. I will tell you examples. Here if you divide them Ey by Ex, then cos omega t cancel. Then you get link between Ex and Ey. Then that follows linear equation. For example, Ex is equal to Ea cos omega t. Then Ey is equal to Eb sin omega t is there. What I do, I will write Ex by Ea is equal to cos omega t. I will write Ey by Eb is equal to sin omega t. I will take this square plus this square, then Ex by Ea whole square plus Ey by Eb whole square, then cos square plus sin square is 1. Somehow I got the equation which gives relation between electric field X and Y, both components are there. Now this is called resultant electric field equation. It looks like ellipse, so it is called elliptical polarization, like that, dear students. Now in this case, how to eliminate the time? You eliminate the time and get the link between Ex and Ey, then that is called resultant electric field equation. So you take equation 2 divided by equation 1, then you get Ey by Ex. This cancel, you get Eb by Ea. So ultimately this is Eb divided by Ea. So Ex, and this is equation 3. It is like y is equal to m into x. So it is linear equation, dear students. So this is linear equation. Here if you take this as a x-axis, if you take this as a y-axis, and then what is this? On xy plane, it is a straight line having slope m. Similarly, this one on ex comma ey plane, this is ex and ey plane, this is a straight line having slope eb by ea. So it is like this, and this is the equation. So this is the equation. Ey is equal to eb divided by ea. It is some constant like slope and ex. Okay, so here equation 3 is a linear equation. So EM wave is said to be linearly polarized. Dear students, I am going to discuss case 1, case 2, case 3, case 4, case 5. In your lifetime, you have to study them only one time. But after studying this case 1, case 2, case 3, case 4, case 5 one time, I will write note. In that note, I will write 3 statements. With those 3 statements, any polarization question is solved without doing mathematics. That is why you listen these statements carefully. So what statement I wrote for this, if Ex comma Ey components are present and both are in phase. In phase means here cos omega t, here also cos omega t. For example, here sin omega t, here also sin omega t. Same phase should be there. Then resultant electric field equation is linear equation. Then it is linearly polarized. For example, What is case 1? You know, if slope becomes 0, then that electric field x component only will present, dear students. In that case, that is case 1. That means case 1 is also linear polarization. If slope becomes infinity, that is parallel to the y, that means only electric field y component will be there. That is case 2. So some finite value slope is there, that is this linear. So that means case 1, case 2, case 3 all are linear. Now I am concluding, if electric field has x component, then wave is said to be polarized in x direction. If electric field has y component, then wave is said to be polarized in y direction. Of course, both belong to again linear polarization only. So case 1 and case 2, comma case 3 are examples of linear polarization. Okay, students. Now I will write the case 4. I will write the case 4. After studying these cases, now we are going to write the note. Our interest is on the note actually, but to understand the statements written in the note, we are discussing uh, these many cases. Now I am writing case 4. Case 4, students. Okay. Case 4. Electric field has a Ex and Ey components, and also they have so and also electric field has Ex and Ey components having equal magnitudes, having equal magnitudes and 90 degrees phase difference. See carefully the statement. Electric field has X component, Y component, both are present, and they have equal magnitudes but 90 degrees phase difference. Then the resultant electric field is circle. So wave is said to be circularly polarized. I will take one example and I will solve this one so that you will understand that what is written here. So example is given like this. Given E naught is equal to E naught vector, that means that is initial electric field vector is given EA AX cap plus J means what, student? 90 degrees. J means 90 degrees. Okay. J means 90 degrees. Again, magnitude is same for both of them. One is X component, other one is Y component, like this. Actually, this is only electric field initial value vector is given. Then how you find phasor? Like this you will find phasor, students. So electric field phasor is equal to E naught bar into e power minus j beta z. Okay, that is equal to ES bar is equal to, this is EA AX cap JEA AY cap e power minus J beta Z. So ES bar is equal to EA into e power minus J beta Z. Okay. E power minus J beta Z AX, then plus J into EA into e power minus J beta Z AY. Now this electric field is in phasor domain. You want in time domain, then electric field vector in time domain is equal to real part of phasor electric field multiplied with e power j omega t. That is nothing but real part of this is EA e power minus j beta z e power j omega t. We are multiplying that with e power j omega t. AX plus EA, this one, plus EA e power minus j beta z e power j omega t. Then this j is there, j is written as actually 90 degrees, students. Then AY cap. So that is EA into, in the exponential here, j common, then e power j omega t minus beta z, real part is cos. So cos of omega t minus beta z EX, then EA. Actually in the exponential j common, omega t minus beta z plus 90. So EA into cos of omega t minus beta z plus 90 is there. So AY cap is there. Now if you see, E bar is equal to like this, and if you write this, if you, this 90 na, this is EA into cos of omega t minus beta z AX cap. This is a 90 plus something. This is second quadrant. In second quadrant, cos is negative, so you get minus of EA into sine omega t minus beta z. So AY cap. Now you, some students may ask me question by seeing this, sir, what is going on here? क्या चल रहा है sir इधर? So students may ask the question, but what is going on, I will tell you. Question can be given in three ways. One way is, in the exam they give this one. They ask you what is the polarization. In second way, they can give this one. They ask what is the polarization. In third way, they can give this one. They can ask you what is the polarization. So what I want to tell you is that this equation is in initial electric field form. This equation is in what do you say, time domain form. Of course this is also in time domain, but here here it is written the equation in such a way, this phase and this phase same, but here some sign changes are there. So dear students, what is going on? Question is going on. What is that question? In exam they give the electric field initial vector is like this, then what is the polarization, they can ask. That is one question over. Second question, in exam they give this equation, they ask you what is the polarization. In exam they can give this equation and they can ask you what is the polarization. So all three equations are same. Now statement also same, you see carefully. The electric field has x component, magnitude is EA. The electric field has y component, magnitude is EA. So same magnitudes are there. But this y component, j means 90 degrees. So y component phase is 90 degrees. It leads, actually y component leads this x component by 90. Don't confuse. Electric field x component is EA. I will write like this, EA. Here electric field y component is JEA. Now this magnitude is EA, this magnitude is EA, same magnitudes, but this has a term like this, nothing is there, so you can write e power j0 and e power j90. This j is so this has 90 degrees phase more than this one. That's why you say y component leads 90 degrees. Or otherwise, we say for wave traveling in z direction, electric field can have x and y components only. This y component is called second component. Second component leads first component by 90 degrees. Then after doing derivation, we get left polarization. Left polarization we get. So if lag comes, then automatically right comes. I will write that in the note. We will solve for second component leads first component by 90 degrees. Then we will get left polarization. That I will write in the note. If lag comes, automatically that is right polarization comes. That is the way you remember. So here also same information. X component magnitude is EA, Y component magnitude is EA. Both have same magnitude. And X component cos term has phase omega t minus beta z. Y component cos term has phase omega t minus beta z. Plus 90 more is there. Plus 90 means leads. So second component leads first component by 90 degrees. Here phases means don't see angle between x and y. That is not the discussion. The discussion is x component has cos term, y component has cos term. What is the phase between them? That discussion is going on. Here also, if minus sign is given, then you will be writing this like this. Then once again you get second component leads first component by 90 degrees. Now let us see the polarization. Now we did not start the discussion of the polarization. Now we are discussing the question only. Now here you write electric field x component is equal to EA cos omega t minus beta z. Electric field y component is equal to here na minus EA sin omega t minus beta z. You can write this. This one also you can write, no problem. Now I wrote given electric field x and y components. Now we are starting the discussion of polarization. अभी शुरू हो रहा है polarization का discussion. अभी तक शुरू ही नहीं हुआ. Polarization is observed at z is equal to 0 distance. Okay. Now at z is equal to 0 distance, Ex is equal to Ea into cos omega t. Ey is equal to minus Ea sin omega t. Equation 1 and equation 2. So equation 1 square, equation 2 square implies Ex square plus Ey square is equal to Ea square is common, cos square plus sin square is 1. Ea square is common, equation 3. So equation 3 is a circle. So EM wave is said to be circularly polarized. One discussion is over. Now whether it is left circularly polarized or right circularly polarized, we have to discuss. For that purpose, we have to change time and we have to observe. Now I will show you. Let us take this here. Let us take this as a, this is the x-axis and this is y-axis. Of course, out of the board is z-axis. On the x-axis, I am taking electric field x component. On the y-axis, I am taking electric field y component. Then z-axis is out of the board. That z-axis is out of the board. That is wave propagation direction. You can see wave propagation direction is plus z direction. Okay. Now, this is electric field negative electric field minus Ey. This is electric field x component negative value minus Ex. So student, if it is a circle means here actually x square plus y square is equal to a square. X square plus y square is equal to a square is a circle equation on xy plane, is a circle equation on xy plane with center 0 0. This is the center and radius is a. So this is the radius a. Similarly, this is a circle equation on ex and ey plane with center 0 0 and radius is ea. So from here to here distance is actually ea comes, students. From here to here, na, this is ea. Here also ea, anywhere ea only. Okay. Now until this, with this equation we have drawn this. अभी तक हमने ये इक्वेशन को लेके ये सर्किल ड्रा किया था हमने. अभी हम लोग टाइम को बढ़ा देंगे, क्या होता है देखेंगे. अलग अलग टाइम में क्या होता है देखेंगे. क्योंकि मेरे को थोड़ा जगह चाहिए, इधर ही लिख देता हूँ, आपको थोड़ा सा ऑब्जर्व करने के लिए आसान रहता है. इधर माइनस ई वाई. ओके. So let us substitute at T0, then electric field X component is EA into cos 0, that is equal to EA, and electric field Y component minus EA into sin 0, you get 0. So, so here you can see time 0, if you put time 0, okay. If you put time 0 in this, then EA into cos 0 is EA. Then you put T0 here, EA into sin 0 is 0. Okay. So at time 0, electric field X component is EA, EY is equal to 0. So whenever time is 0, only electric field X component is there, that value is EA. So this is the tip of the electric field. This is the tip of the electric field when time is equal to 0, student. This one. Once again I am telling, at time 0, electric field X component is EA, electric field X component is EA, but Y component 0 means no need to have Y value here. So only electric field X component is giving the overall. See here, EY 0 you put, so EX square is equal to EA square. Now EX is equal to EA. At time 0, tip is here. What I am telling you is that electric field tip is a circle actually here. Now that tip at t is equal to 0 time is here. The tip is here now. Okay. Now let us substitute next time. At t is equal to t by 4 time. At t is equal to t by 4 time, what happens? Omega t. Omega is 2 pi by t into t is t by 4. Now tt cancel, you get what you get, students? This tt cancel, pi by 2 you get. Now from this electric field X component is equal to EA into cos pi by 2, cos pi by 2, that is equal to 0. Similarly, electric field Y component is minus EA into sin omega t. Omega t is nothing but pi by 2. So you get minus EA. That means when time is increased from 0 to t by 4, then electric field tip was at on the x-axis. Now electric field tip moved onto the minus y-axis. EY is minus EA means downside, that is. This is plus EA for EY. This is minus EA on EY. So tip came here at time. I will write this here. So this one is minus EY. Now at time t by 4, at time t by 4, I will write here t by 4 time tip was here, the value is minus EA. So this is minus EA, this one. That means at time t0, electric field tip was here. As the time is increased, then the tip is moving like this. Tip moves like this. So tip is moving in this direction. Arrow mark is given, no? That is more than enough. So if time increases, electric field tip is moving in this direction. At time 0, tip was here. Then time increased at t by 4, tip came here. For example, t by 8 you substitute, it will be coming somewhere here like this. Now resultant electric field shape is circle, so it is called circular polarization. Now we have to find whether it is left circular polarization or otherwise right circular polarization we have to find. For that, one method is there. You take the left hand, then put the left hand thumb in wave propagation direction. Then if these closed fingers are in time increase direction, then that is left circular polarization. You take the right hand. If the right hand thumb is in wave propagation direction, you put the right hand thumb in wave propagation direction. Then if these closed fingers are in the time increase direction, then that is right circular polarization. Now I am showing here and I will write that statement also. You need not to worry about that. Now what is dot? Dot means out of the board. Z axis is out of the board. Wave is traveling in which direction? Wave is traveling in plus Z direction. Be careful. For minus Z direction again statement will change. Wave is traveling in plus Z direction. Put the right hand thumb in wave propagation direction, that is plus Z direction. Plus Z direction is out of the board. Now these closed fingers are not in the time increase direction. Time is increasing in this direction, but this is opposite, you see. So that means it is not a right circular polarization. Now take the left hand. Put the left hand thumb in the wave propagation direction, that is positive Z direction. Now these closed fingers are in the time increase direction like this. Now this diagram matches with the left hand, so that is why it is a left circular polarization. So I am going to write the statement there. Now student, I am telling the statement for left circular polarization LCP. You remember that one, this is LCP. What is the reason? LCP means left circular polarization. Because resultant electric field is circle, so it is circular polarization. Now put the left hand thumb in wave propagation direction, then closed finger is in the time increase direction. So that is why it is left circular polarization. What statement you have to remember? The statement is wave traveling in plus Z direction and electric field, both components have same magnitude and second component leads first component by 90 degrees. So for wave traveling in plus Z direction, both x and y components have same magnitude and second component leads first component by 90 degrees, then that is LCP. In that statement, two crucial things are there. Wave traveling in plus Z direction and second component leads first component by 90 degrees, then you get left. If second component lags, then left becomes right, because tip will be moving like this. Or otherwise, second component leads first component by 90 degrees and wave traveling in minus Z direction, then also left becomes right. I will write that in the note. After doing this much mathematics, those statements are only useful to you to solve the questions. Every time you cannot do this mathematics and decide. Once if you do this mathematics, we will write the statements there. Now for this, I am writing the statement here. So dear students, I am changing the pen. Here, I am writing the statements here. Hint for you, this hint, na? If left hand thumb is in wave propagation direction. Of course, in this case, z direction. In this case, I am telling. So, if left hand thumb is in wave propagation direction and left hand closed fingers are in time increase direction. This time increase is also called as a time advance. Time advance. Advance means increase. Then it is called left polarization. It is called left polarization. That means in case of circular polarization, it is called left circular polarization. If it is elliptical polarization, then it is called left elliptical polarization. So similarly, if right hand, if right hand thumb is in wave propagation direction and right hand closed fingers are in time increase direction, then it is called right polarization. So based on this, we have decided that this is left circular polarization. Once again I am telling why. Here wave propagation direction is z direction. In this diagram, the z direction is out of the board. Put left hand, this is left hand, put left hand thumb in z direction. That means wave propagation direction. Then the left hand closed fingers are in the time increasing increase direction. Time t0, t by 4, time is increasing in this direction. So it is left circular polarization. Can you tell me what is the statement for left circular polarization? For wave traveling in plus direction, both have same magnitudes and the second component leads the first component by 90 degrees. In that statement, lead becomes lag, then left changes to right, or otherwise it is lead is there, but if wave travels in negative direction, then also left changes to right, dear students. I will write that in the note. Now can you tell me what is the case 5? If case 1, case 2, case 3, case 4 are not valid, that is automatically elliptical polarization. For that, so many cases are there. That is the way you check the polarization. First, you check for linear polarization. For linear polarization, both components should have same phase. Then if they have same phase, you tick mark the linear polarization. If they don't have same phase, you check for circular polarization. Circular polarization means both should have same magnitudes and phase difference should be 90 degrees. If both the components have same magnitude and phase difference is 90 degrees, then circular polarization. If circular polarization also failed, then no need to check, that is elliptical polarization only. Then in that case, if second component leads first component, that is left elliptical polarization. So case 5. If electric field has Ex and Ey components having unequal magnitudes and 90 degrees phase difference, then resultant electric field tip is ellipse. So EM wave, that means wave, is said to be elliptically polarized. Example we will take. Given electric field EA into cos omega t minus beta z AX cap plus. So same equation is given, and here EA is kept, here EB is kept. Here EA and EB, different magnitudes are there, then automatically the equation becomes ellipse, students. Okay. I can do in this only modification. Anyway, no problem. EA cos omega t minus beta z AX, then EB cos of omega t minus beta z plus 90 degrees AY. It is given like this. Then automatically here omega t minus beta z plus 90 is there. So it leads actually by 90 degrees. EA and EB both have different magnitudes, right? Now that is EA cos of omega t minus beta z AX minus EB sin of omega t minus beta z AY cap. So here electric field X component is EA cos of omega t minus beta z. Electric field Y component minus EA sin of omega t minus beta z is there, minus EB, no, it is EB sin of omega t minus beta z is there. So polarization is observed at z is equal to 0 distance. So now that becomes EX becomes EA cos omega t, so equation 1. EY becomes minus EB sin omega t, equation 2. So now EX divided by EA is equal to cos omega t, and EY divided by EB is equal to minus sin omega t, equation 4. So equation 3 square plus 4 square is equal to EX by EA whole square, then cos square omega t, EY by EB whole square, then sin square omega t becomes 1. So equation 5 is an ellipse. So wave is said to be elliptically polarized. Now once again you take like this diagram. In the diagram you take this is x-axis, you take this is y-axis, and this is minus y-axis, and this one is minus x-axis. Now you draw the ellipse like this. At the time t is equal to 0, Ex is Ea cos 0, you get Ea. This is minus Eb sin 0, this is 0. At time t is equal to t by 4, omega t becomes 2 pi by t into t by 4, pi by 2. And in equation 3, you can substitute Ex is equal to this one, equation. Okay, equation 1 you substitute. Ex is equal to Ea into cos pi by 2, 0 you get. Uy is equal to minus Eb into sin pi by 2. So this is minus Eb into sin pi by 2. You get minus Eb. So that means at time t is equal to 0, Ex is having only Ea here. At time is equal to 0. This is Ex is equal to Ea. And at time t by 2, t by 4, then Ex is 0, Ey is there minus Eb. So like this, this is minus Eb, this one. At time t is equal to t by 4 time. That means time increased now. So this tip is going like this, elliptical tip is going, if time increases, tip is going like this. Now this is x-axis, y-axis, out of the board is z-axis. The wave propagating in z direction, that is out of the board. You put the left hand thumb in the wave propagation direction, that is z direction. Then these closed fingers are in the time increase direction. So this is left elliptical polarization. So LEP, left elliptical polarization. So this is LEP, students. So in this way, wave is traveling in plus z direction and both have different magnitudes, and second component leads the first component by 90 degrees, and that is left elliptical polarization. Even if phase difference is not equal to 90, then whatever difference term is there, that comes to the denominator, and so that once again it becomes elliptical polarization only. So here, after discussing these many things, you have studied only one time. Now no need to study them again and again. I am going to write 3 statements in the note. You have to read the 3 statements carefully. By reading those 3 statements, you can solve any polarization question, dear students. Okay. Now here one point is there. If you want to observe, you can observe that one. What is that? Axial ratio is defined as a major axis by minor axis. So this is major axis and this is minor axis. Okay. Now, okay, I will write that here. Can I use this place? I am using this place now for that. Okay. For this, let us say this is O, origin. This is A. This is O, this is A. Now I am removing everything here. This is OA. This is O, this is B. OB. This one. This is called minor axis and this is called major axis. This is OA. So minor axis length is 2 into OA. Major axis length is this is OB. So major axis is from here to here. That is 2 times OB. That is called axial ratio. So here axial ratio, simply that is called AR, is defined as a major axis divided by minor axis. So axial ratio here is defined as a major axis is 2 times OB divided by 2 times OA. Simply that is OB divided by OA, 2 cancel. First one, if OA is equal to 0, that means this width is 0, this is also 0, then it looks like a straight line, then that is linear polarization. So if OA is 0, implies axial ratio is equal to, if OA 0 means axial ratio becomes infinity, then that ellipse becomes a line actually. So now that ellipse becomes line. That means OA 0 means this width is 0. It looks like a line. So it is a linear polarization. Okay. Next, second one. If OA is equal to OB, that implies axial ratio becomes 1. Dear students, OA is equal to OB, this OA and OB are equal, the shape will be a circle shape, then the shape will be a circle shape, so it is circular polarization. Circular polarization. That means if axial ratio is infinity, that is linear polarization. If axial ratio is 1, in case of ellipse, if axial ratio is 1, that is circular polarization. Now, if axial ratio is exactly 1, that is circular polarization. If axial ratio is exactly infinity, that is actually linear polarization. If axial ratio is between 1 and infinity, then that is elliptical polarization. So, third case, if axial ratio is from 1 to infinity, axial ratio equal to 1 means circular polarization, equal to infinity means that is linear polarization, then 1 to infinity means then it is elliptical polarization. Elliptical polarization. Now I am going to write note here for different polarizations. I told you I will write 3 statements. I will write 3 statements. Now, in polarization, this note you have to study, students. First note, if Ex comma Ey components have same phase, they are also called as in phase. In phase means same phase. Then polarization is linear polarization. Okay. Components have same phase. Then it is linear polarization. You listen the statements carefully. First, if any polarization question is asked, then you will be checking for linear polarization. If both have same phase, then you tick mark linear polarization. Then if both doesn't have same phase, then you will be checking for circular polarization. If circular polarization is passed, then you put circular polarization. If that is not circular polarization also, then automatically no need to check, that is elliptical polarization. So, second statement, if Ex, I will write here wave traveling also. For wave traveling in plus z direction, for wave traveling in plus z direction, if Ex and Ey have same magnitude, if Ex and Ey have same magnitude, and second component, that means that is Ey actually for wave traveling in z direction, leads second component leads first component, that is Ex student here, first component, then it is left circular polarization, simply LCP. Here you have to observe very clearly, then automatically elliptical polarization is very simple. First statement you see carefully. Ex and Ey components have same phase, then it is linear polarization. If linear polarization test is failed in the question, then you check for circular polarization. Circular polarization for wave traveling in plus z direction, if Ex and Ey have, they should have same magnitude should be there, and second component and first component 90 degrees should be there. Here 90 I have not written, I will write. If second component leads first component Ex by 90 degrees, it is very important, by 90 degrees, then it is left circular polarization LCP. So if wave is traveling in z direction, then Ex and Ey have same magnitude, and second component leads first component by 90 degrees, then it is left circular polarization. Here, if you change lead to lag, then left change to right, and also if you change plus z to minus z direction, then also left is changed to right. So for your convenience I am writing here, in the same, if minus z direction is there, then everything is same, that means lead is there, then here it becomes RCP, because some students confuse, that is why I am telling all the four cases very clearly. Okay, then here plus z direction comes, okay, lead is changed to lag, then once again everything is same, here it becomes LCP. Now once again wave is traveling in minus z direction, and again everything is same, so here again lead comes, so here it is better I write the word. So here plus z direction lead LCP, Then minus z direction. Direction is changed, but lead is there. That L becomes right. So here plus z direction is there and lag is there. So in that case, once again, left becomes any one change is there, then left becomes here, no? Third one, no? Plus z direction is there, lag is there. Then again left becomes right, students, because only one change is there, na? RCP. Okay, only one change is there. Actually, you remember first statement, that is wave traveling in z direction and lead is there, that is LCP. If any one term changed, maybe z direction changed to minus z direction, or otherwise lead changed to lag, then left becomes right. Okay, so here plus z direction, lead, left circular polarization, minus z direction, lead, then right circular polarization. Again plus z direction, lag, this is again right circular polarization. Both change, na? Wave traveling in plus z direction, now it is traveling in minus z direction. Lead becomes lag, na? Now we have to take lead, lag. Okay, lead becomes again lag only. So here wave direction also changed. For that left becomes right, and again lead changing to lag, then again right becomes left. So once again it is LCP. So now which statement you have to remember? Only this statement you have to remember, and no need to remember other statements. If you remember the statement, that is LCP, you change plus z direction to minus z direction, then that what you have remembered left becomes right. So this is maintained same, left becomes right. And you have remembered wave traveling in plus z direction and lead, that is LCP. Now it is maintained same, but lead becomes lag. Now that left becomes right. You have remembered wave traveling in plus z direction and lead, for that that is LCP. Now you change plus z to minus z, that LCP becomes RCP. Now again you are changing lead to lag, that RCP becomes again LCP. So this is the statement which you have to remember. Now no need to remember for elliptical polarization. If that is not circular polarization, automatically that is elliptical polarization. And for elliptical polarization also same statements come, that for wave traveling in plus z direction, if second component leads, then that is left elliptical polarization comes. Similarly other things also. I am not writing for the elliptical polarization. In an exam question you test for this. If it is linear you tick mark. If it is not linear you test for circular polarization. If it is circular polarization you tick mark that. If circular polarization statement is not matching, then automatically elliptical polarization. So these statements only, now you have to remember two statements. For linear polarization one statement, for circular polarization one statement you have to remember. Automatically if that is not linear, that is not circular, automatically that is elliptical polarization. We will solve the question, you will understand.